Hey gang, Mocha Boy here. Got another tutorial for you. So this was a sort of a request that came through on the boards. It was actually a request in the form of, can you please build this for me? Which is great, but you know, I thought I'd also take the opportunity to document this while I was doing it. So what we're doing here is we have a Mobius Actioncam, and if you don't know what this is an $80 camera that pretty much rivals the GoPro in all but the worst light. It's a 1080p camera that does up to about 30 frames per second. So it's not quite the 60 frame or 4K that you'll get with a GoPro, but it's still pretty damn impressive, at least you know, from an FPV perspective. The images that you get out of here maybe not be as pin sharp as GoPros, but you know, it is, as far as I'm concerned, more than usable. And you know, if you crash your rig and you lose one of these $80 cameras, it's going to feel a lot less painful than losing a $300 or $400 GoPro Black Hero 3 Plus. So anyway, these are great little cameras. They are the latest iteration in the keychain camera series. So the keychain camera 11, 16s, you know, all great cameras. You know, they finally listened to the end users and changed the form factor around, so it wasn't that bulky kind of keychain fob looking shape, but it's actually flat and it's rectangular. Interestingly enough, the lens is actually removable, or not so much removable, but relocatable, in the sense that there's a header right in the middle there where you could remove this and then take that lens and put it someplace else, you know, extend it beyond where this actual camera is. And that has a lot of really great possibilities that we're probably not going to go into here, but I did want to mention that only because it's so interesting. So anyway, what we're trying to do here is we need to create a cable for this Mobius Actioncam that does a couple of special things. First of all, it'll be responsible for charging the camera during flight, so it'll be providing an active power source to the Mobius, but it'll also be providing a video out from the Mobius to a video transmitter. That's not always going to be the case, and you know, we'll put the video out cable in there just in case you want to use it. But you know, a lot of people will opt to use a combination of this plus, say, a CCD camera, or just this, you know, maybe in a plane. I'll leave it up to the pilots to figure out you know, how they want to use this, but you'll have the option with this. So just a couple of things before we get started here. There are some very special considerations that you have to make for operating this camera. These have pretty high amperage requirements, more so than most components that you'll find on FPV rigs that are around the 100 or 200 milliamp range. You need something on the order of about half an amp of a power source to be able to operate this in a clean fashion. If you operate with anything lower than that, you're going to run into issues. That's why one of the things that you can't do is you can't plug this into like a receiver port, which is only good to maybe about 125 milliamps. You can't plug this into a flight controller, again, which is only good to maybe about 200 or 250 milliamps. So what you need to do is you actually need to connect this into a direct power source, which in a lot of cases is going to mean into a 4-cell power rail or a 3-cell power rail. And if I could give you an example of what that would look like, again, this is that 3D printed quadcopter. Hang on a second, I'm going to show you the bottom side of this. Under here, there's the 4 ESCs and then a single copper PCB strip that I use for my power distribution. And it's actually got two sides, positive and negative, and all you do is you run a tap from there directly to the front of the rig, and then that's where you'll be connecting the Mobius power rails into. So that's problem one. Problem two is, what are you going to do with you know, a 16 volt or 12 volt power supply? You obviously cannot feed that into the Mobius directly, or you'll end up burning it out. So you need to step it down, and that's where this component comes in. This is actually a really great find. I've been hearing about these on the boards for a while, but only just recently started to find some reliable sources for them. If you go on eBay and look for these are 3 amp DC-DC step-down micro converters. And in this size, you're not going to find anything else that has, you know, this many inputs and outputs and is capable of an output up to about 3 amps. Now, just a note there, they say 3 amps, but you know, to safely operate this, I would say stay around 2, because I've actually read the data sheets on a few of these switching regulators, and they say it's good up to 2 amps, but it's also good up to 3 amps if you can provide active cooling, which is usually in the form of some aluminum fins or, you know, some good airflow. Now, what part of the issue here is that this is going to be covered under heat shrink, so airflow is going to be a problem. So just a consideration for you as you're planning these out. You want to make sure that you're keeping your amperage pulls, you know, about around the 2 amp range, and you should be fine. It might get a little warm, but you should be okay. So yeah, really great find, and this is only $2, if you can believe that. I mean, minus the shipping, of course, which is just nuts for something that's this big. Plus, this particular package has 2 inputs as well as 2 outputs. So from this one power distribution, from this one step-down converter, you could feed a video transmitter as well as your 12-volt camera. Unfortunately, of course, after you step down the voltage, you only get 1 voltage, so you'll have to run 2 12s or 2 5s, but not a 12 volt and a 5 volt, like a 12 volt VTX as well as a 5 volt camera. Now, the way that you do that is by this adjustable trim pot right here. So you just take a screwdriver and then turn that until your multimeter says about 5 volts, and then you're golden. So this is actually an example of one that is just about done. Power comes in this way, and that's the input ports here. And as you can see, what I also did was I tapped the 12 volt side of this. So let's assume we're sending 12 volts in from here. You can add in 2 additional leads here, and then this is another 12 volt supply out to, say, like a camera, you know, 400 milliwatt RMRC 1258 camera. And then, as you can see, this is, you'll probably recognize this pinout. You'd have your video signal, power, and ground. Now on this side, these are the outputs, and on a multimeter, again, what I did was I turned that trim pot until I saw about 5.1 volts, and this is what's actually going to go out to the USB port. And then this USB, this is a USB Mini B plug that I sourced from Allied Electronics. You can actually find these on eBay and DigiKey. They're about $1 a piece for the entire assembly. And this is what they look like before you put them together, and I'll go over that in just a second. But this will go into here, and once you plug that in, you'll have an active power source to power your Mobius camera for however long you're flying. So if you're flying in the cold and, you know, that sucks your battery down to about 10 minutes. This is very useful for keeping that battery going for as long as your flight batteries are going. So anyway, these regulators were really fantastic, and again, for $2, I mean, I use these for just about everything on the rig. For those of you interested in the UHF scans, you know, we're talking like millivolts of ripple, as well as you know, a switching frequency down in the single-digit megahertz range. So these are fine on the UHF. They scan clean on the UHF frequencies and any of the other frequencies of concern. So these are pretty great. The only thing that I'd be concerned about is this inductor. It's a really big inductor, so I wouldn't want to keep this close to anything that might be susceptible to magnetic interference. So don't put this next to the magnetometer of an APM or some other flight controller. That's about the only caution that I can give you. So let's move on. Now, like I said, I was actually a little surprised at how challenging this was. So you would have noticed that there's a resistor here. We're not actually going to use this resistor. The reason that I have this is because of the lead. I needed to snip off a tiny piece of this lead so that I could short the pins on here. And I'll explain what that means in just a sec. So the trick here with the Mobius cable is when you plug this plug into there, there's a sense pin. Well, let's go through the pins here. So from right to left, it's pin 1, 2, 3, no connect, or at least in the case of the Mobius, the sense line, and then pin 5 is ground. Now, the way the Mobius knows to send video out is that the sense line is shorted to the ground line. So that means pin 4 and pin 5 are shorted, and that's where this lead comes in. I cut off a tiny little bit of that lead, and then I throw on some solder paste right about there, and then just zap it with a heat gun for about 5 seconds, and that shorts these two pins together, and then puts the Mobius in video out mode. Because as you can see, what's strange about the output of this is that you have 5 pins here, but there's only 4 outputs. So it's pin 1, pin 2, pin 3, and pin 5. And then pin 4 and 5 is what will get shorted, and then this will be our oops, sorry, turn it around. So yeah, as far as the pin outs are concerned, from right to left it'll be VCC, video out, pin 2. Pin 3 we won't use, but if you were using audio, that you'd use pin 3. And then pin 5, or at least 4 in this case, is going to be ground. So to actually do this requires quite a bit of dexterity, as well as some really tiny tools. So I know that not everyone's going to have a hot air gun. So if you don't, you can also use like a really tiny tip. Like let me see if I have one here. You could use something like this, an SMD tip, to be able to short those 2 pins, and you need to do it on this side because there's just nowhere else to do it. So yeah, that's basically it. Like I said, it's a fairly delicate operation. This does require a bit of surgical precision to get right, and this is what the end result could look like. The guys who requested this requested just that these leads be open, and they'll clip on their own connectors. But for this, I'll put a female servo pin connector. And, just as a rule of thumb, if you're ever supplying power out, you always want to make sure that that's on a female pin that's protected in a housing. You don't want male pins sticking out with active leads. You don't want that running around in your bag, shorting things and frying things in your bag. So always use these female headers for anything that's going to supply power. For power inputs, and that's where you'll use your male pins. So I think that's all of the considerations. Now just one other thing. As you can see on here, I originally started with servo wire. This is like 24 gauge servo wire, which is really thick and really ungainly to work with. I did run into a few problems working with this. The coating on here is just really not suitable for any kind of soldering. So this was on fairly low heat, and it melted right through. So I'm going to switch over to my 28 gauge wire. This is 7-stranded wire. The coatings on here are good up to 250, 300 degrees Celsius. So we're not going to have too many trouble with that. So yeah, I'll give you I'll step you through what some of the surgery is going to look like, and by the time we're done, we'll have a working power cable. All right. Okay, so we're going to start with the hardest thing first. What we need to do is we need to short pins 4 and 5, and that's sense to ground. And in order to do that, what we're going to do is we're going to take this lead, clip off a tiny little bit of it, place that in there, and then solder that together. So let me show you what this is going to look like. This gets a little crazy because these parts are extremely tiny. Oh, too tiny in this case. All right, let me try that again. And we're talking a piece about 1 millimeter wide, so this is some pretty serious surgery here. All right, so you know what? Before I put that out there, I'm going to lay down some paste. And the reason that I'm using paste is because these casings aren't rated for direct contact with a soldering iron, so if you touch these plastic casings will probably melt, more than likely melt. So the solder paste allows us to get that paste on there without direct contact. 700 degree tip coming into contact with that. So that's what I do. Lay down some paste on both pins, and then just shove that pin right in there. I'm going to turn on my heat gun. This is dialed into about 650, 700 degrees Fahrenheit, 300 C. And then I'm going to zap this real fast. It shouldn't take more than a few seconds. So let's see how this works now. Yeah, much better. Wow, this is challenging. Okay, so here's what we've got. Pins 4 and 5 are soldered, and now we're ready to go ahead and print in the other side. So we're going to flip this around. As you can see, again, there's only 4 pads here because we already shorted pins 4 and 5, and that's going to go to these pads here. Okay, so just go ahead and grab my dollop here, and we're only going to be doing pin 1, pin 2, and pin 5, or pin 4, 4, 5. Put a little paste there. A little paste there. And a little paste there. Alright, so here we go. 1, 2, 3, done. Alright, so what we're going to be doing is we're going to be soldering pads 1, 2, and 4/5 on the end. Now the way it goes is VCC. Goes VCC, signal, or video signal out, and then ground. So I like to start from the inside and then work my way out. That way it's a little less crowded. This wire is pre-tinned, and then there's a little bit of solder paste on the pad to begin with, and I'm using my microfine tip just to make sure that I'm not melting the sides. So I'm just going to drop that on there. Alright, looks like we got a good connection. Okay, let's do the VCC line. Okay, good connection there. Here we go. Alright, and there we go. So those are, let me just shut that off. Okay, so now that we've got all the pins in, let's just double check, make sure they're nice and secure. Good. So that's our connector, and let's see. This connector goes into the housing, slides right in, and this is going to go all the way through until this tip is flush with this tip. So for this, I mean, this is fairly simple. You just pop that in, and then I like to have like a little micro screwdriver handy to just push that in. And when the plastic tab is flush with the edge, you're in good shape. And then to lock this all up, there's this last piece here. This mating tab, this mating connector goes right in that slot right there. And then these 2 sets of pins, those 2 sets of locking tabs will just snap into place once I load this. So you just want to make sure that your wires are tucked away before you snap this shut, or else you'll have to pull that back open and then do it again. And that's it. So then at this point, just hit this with your crimper, and you'll have at least the business end of the connector done. Now all we have to do is just grab the heat shrink and drop that on top. And the heat shrink's going to go to just about there. And the way that you know this is just plug it in and see wherever it stops. Okay, so plug it in to the Mobius, and then just push the heat shrink right up against the edge, pull the whole thing out, and then hit that with some hot air, and your at least the business end of this is done at this point. So let's just hit this with the hot air gun. I'm making a few assumptions of how you have your rig set up, and the assumption here is that you're feeding 12 volt in to the power regulator. And if that's the case, then you can get another 12 volt rail to go straight out to the video transmitter, which is fine. But if you're pulling in, say, a 4-cell setup and that's 16.8 volts, then obviously this is not going to work out, and you're going to have to, do another pigtail to maybe another voltage regulator to get, to get that regulated 12 volt out. So just be careful with how this is set up. On the finished cable, you have 12 volt coming in, and then since these pads share the same rail, this is just another set of connect. This is the same thing as just doing like a Y harness and then sending out another 12 volt tap. And as far as the signal cable is concerned, it's just going to loop back around like that and then terminate right there with the other 2 power leads out to the video transmitter. So you'll have video source and then video out. So that's the way that's set up. All right, so first things first, let's get these edges pre-tinned, these tips pre-tinned, and then we'll make it a lot easier to drop into the regulator. And interestingly enough, here's my spool from Radio Shack. This is a 2.5 ounce spool. Look how much is left. All right, so anyway, I'm doing a lot of soldering. 1, 2, 3, 4, and we're done. What I'm doing here is I'm pushing this way so that it's flush with the wire. I'm going to grab a little solder and then hit it on this side until it stays. Okay, so that's one. Good, and that's it. Okay, so almost done. We just need 2 more wires to go from the 12 volt input to 12 volt output. We should be done. Alright, so here's where we're at, folks. All the soldering's done. The board's all in and connected up to a 5.8 gigahertz transmitter right here. And actually what I did was I removed the 3-pin connector and I substituted it in for a 2-pin header and a single pin header for the video. So that's going to go in to that immersion RC transmitter right there, just like that. And then what I also did was I hooked up my hot air station. It actually has an adjustable power output. Dialed that into about 12 volts. Let me pull this out so you can see. So dialed that into about 12.1 volts. And this is one of the reasons I love this little soldering station, this hot air rework station so much. It runs a lot of different duties on my bench. So that's running at 12.1 volts, and then that just comes out to the input leads for the power regulator. So that's going to send 12 volts right into the 5.8 gigahertz transmitter, but then 5 volts into the Mobius. And what I'm going to do is got my Fat Sharks over here on the side with a PVR screen, and yeah, we'll be able to show you how the Mobius video out works. So let's get everything connected. That's connected, that's connected. This is going to go into here. And we'll leave that right there. That's connected. The the headset's on, so let's go ahead and turn this on. So let's, actually, you know what? So that's feeding power to the transmitter, and then let's go ahead and plug this guy in. You're going to see blue light, green light, and boom. Let's see if you can... We've got a video out from Mobius. Let's see. We're all done. So, looks like that worked. Yeah, again, now the reason that you go through all this trouble is because you know, the onboard battery sometimes just isn't enough for your long-range flights, and you know, it's always helpful to have an active power source, because as you're using this is also charging the battery, which is really useful. Just to finish this up, what you should probably do is either grab some clear heat shrink, or even some just regular rubber heat shrink, and just toss it right over there and secure it. One other thing that you also should do is get some hot glue and just drop it right on the trim pot, and make sure that you know, that doesn't move, you know, so as you're handling all of the equipment, that doesn't move, and you know, suddenly it's outputting 5.5 volts. Actually, let's shut you off and then pull that out. Other than that, if you made it this far, thanks for watching. Hope that was helpful. This was, I have to say, this was a little bit more challenging than I'd expected, and only because of the connectors that I had on hand. It was really difficult to short that pin 4 to pin 5 without bridging any of the other pins. But if you can do that, you're pretty much home free. Again, these regulators are available on eBay for about a couple of bucks, and you know, if you're going to get them, get a handful of them, and they're $2. You'll use these for different things, especially in your FPV rigs. You know, they're quiet on the UHF bands, and they're just useful for so many different things, especially when you consider they can pump out about 3 amps. So yeah, that's where we're at. This was a lot of work, and you know, if you happen to have the components, then more power to you. Absolutely go for it and go do it. If this is too much trouble for you to put all of this together, there are a couple of flyers on RC Groups and on FPV Lab. A user by the name of I'm not sure if I'm pronouncing this right, but Chan Yote, ChanWyote. You know, if you just do a search for Mobius power cable, you should be able to find his listing. He makes these as well, and you know, from the responses that he's been getting on the for sale threads, it looks like he's doing a great job with those. So yeah, I mean, if you want to go ahead and put yours together, though, now you know how we do what we do. Apart from that, that's pretty much it. If you have any questions about what you saw, or need me to clarify anything else, just drop it in the comments, and don't forget to like and subscribe. Thanks for watching.